Hello and welcome back to another session from our Basic Electrical and Electronics series. In today's video, we'll be learning about a very important and practical topic, effect of temperature on resistors. Let's begin. In this session, we will cover how temperature affects resistance, the mathematical expression for resistance, factors that affect the resistance value, the concept of resistance temperature coefficient, and the temperature coefficient of resistance. These are the basics you need to understand the behavior of materials in different electrical conditions. Let's start with the definition. Resistance is the property of a material that opposes the flow of electric current. It is denoted by the letter R, and its unit is the ohm, written as the symbol omega dot. Materials with low resistance allow current to flow easily. These are called good conductors like silver, copper, and aluminum. Materials with high resistance block current flow. These are insulators like glass, rubber, and paper. Now, let's look at the formula for resistance in a conductor. R is equal to rho times L divided by A, where R is the resistance in ohms, rho is the resistivity of the material, L is the length of the conductor, A is the cross-sectional area. This equation shows that resistance increases with length and decreases with more cross-sectional area. There are four main factors that affect resistance. First, length of the conductor. Second, cross-sectional area. Third, type and nature of the material. Fourth, and most importantly, temperature. Now let's focus on how temperature affects resistance. Temperature can affect resistance in three different ways, depending on the material. First, for pure metals, resistance increases as temperature increases. The graph of temperature versus resistance is usually a straight line. That's because metals have a positive temperature coefficient of resistance. Second, for alloys, the resistance also increases, but the change is smaller and irregular. In fact, some alloys like Eureka and manganese are designed to have very little change in resistance with temperature. Third, for insulators and semiconductors, resistance actually decreases with rise in temperature. These materials have a negative temperature coefficient. Examples include rubber, glass, paper, and even carbon. Now let's talk about the temperature coefficient of resistance. Let's say a metallic conductor has a resistance of R0 at 0 degrees Celsius, and when it is heated to T degrees C, its resistance becomes RT. The change in resistance depends on the initial resistance R0, the rise in temperature T, and the material of the conductor. Here's the key formula. R of T, R of 0 is equal to alpha times R of 0 times T, where R of T is resistance at temperature T, R of 0 is resistance at 0 degrees Celsius, alpha is the temperature coefficient of resistance. So, alpha tells us how much the resistance changes. For every 1 degree Celsius rise in temperature, it is a material-specific value. For example, copper has a higher alpha than an alloy like manganese. This concept is very important in designing electrical circuits, especially where temperature stability is needed. And that's all for today's video on the effect of temperature on resistors. We discussed the basics of resistance, the formula, how temperature affects different materials, and the concept of the temperature coefficient. If you enjoyed this explanation, do like, share, and subscribe to the channel. Thanks a lot for watching, and I'll see you in the next session.